Welcome back to Mo Island. This time you are going to enjoy your stay even better. Why? Because my Mo Island is actually an archipelago. That's right. We have so many options for you to stay on your vacation. Just wait and see what we have in store. Did you know that there were two Mo Islands? There's Mo Island A and there's Mo Island B. Mo Island A has Graham Island and Adams Island, and it has Liter Island. Remember how to get to and from? When you want to go to Graham Island, you have to leave Mo Island, go to Graham Island, and then you have to go back. And for that, you need molar mass. Now, how do I get to Adams Island? Can I go this way? No. No, you cannot go that way. That is death, sharks, blood. You can't go that way. You have to go from Mo Island to Adams Island and then back to Mo Island again. Using Avogadro's number, 6.02 times 10 to the 23rd. And then we did touch on this little Liter Island all by himself down there in the bottom. Liter Island of a gas. And the only way to get to him is to take Mo Island and 22.4 and then go back. However, Mo Island B, our new vacation place, also has Graham Island B and Adams Island B and Liter's Island B. Do you think that you can go from this Liter Island to this Liter Island? No. No, you cannot. Storms, big waves, sharks, everything happens there. No, no, no. The only way to get to my B vacation resort is to go from Mo Island A to Mo Island B. And from Mo Island B, you can go here and back and here and back and here and back. And the nice thing about Mo Island B is that there are no new things to remember. You still have molar mass, 6.02 times 10 to the 23rd, and 22.4 liters to go there. Now, if you are on this island right here, and you want to go to this island over here, the only way to get there is to go back to Mo Island B, then to Mo Island A, and then up to Graham Island. And how do we do this? Is there a special boat that goes here? There is. There's a very special boat. And what is it called? Do you know? I'll give you a minute to guess. That's right. It is the molar ratio. Yes, and we get that from the equation. You might hear me call it equation molar ratio. Hey, when you solve for your stoichiometry problems, I want you to keep a little process in mind. First thing you got to do is balance the equation. Always double check. It might be 1, 1, 1, 1, 1, but always double check. First, you got to convert everything to moles. Then you've got to use your mole ratio, and then you want to convert to the ending unit. Okay, so let's start with this first problem. All right, first let's balance. I look over here, and that lead to nitrate right there has 2 nitrates. And I notice there's only 1 over here, so I'm going to put a 2 there. which makes my sodiums 2. So I'm going to put a 2 there, and then check my chlorines and my leads. So this is balanced. So this is a 1 to 2 to 1 to 2 ratio. Okay, how many moles of lead 2 nitrate are needed to produce 49.35 grams of sodium nitrate? Okay, first of all, if you don't know who lead nitrate is in the reaction and sodium nitrate is in the reaction, we have a little bit of a problem because this is how they're going to be given to you for the most part. Okay, so it says that I have 49.35 grams of my sodium nitrate, which is this guy. So I have 49.35 grams of that. And I want moles of this guy. So how many moles of him are we going to make? So the first thing I'm going to do is I'm going to convert into moles and then use the ratio and then convert to the ending unit. So I have 100 grams of NaNO3. I'm going to want to get rid of grams of that. So I need molar mass, and the molar mass of that is, okay, so my molar mass on the bottom there. Now I'm going to set up my equation molar ratio and use the coefficients in the problem. For every 2 moles of NaNO3, I have 1 mole of PbNO3 lead 2 nitrate right there. All right, so this right here, this is my ratio. All right, and then finally, it wants moles of lead nitrate. Oh, so we're going to stop right there because my grams will cancel out, my moles of NaNO3 will cancel out, and I'm left with moles of lead 2 nitrate. Okay, so I just multiply across the top and multiply across the bottom, divide, and I get 0.2903, and that is moles of lead 2 nitrate. Okay, let's try that again. Now I have a new equation, and I need to first balance it. So, okay, let's see, I've got copper there, silver there, NO3, there's 2 of them over there, so I need a 2 there. When I do that, I make my silver 2, so there I have it balanced. Now it says how many grams of silver are produced when that many grams of copper react. So, I have 32.92 grams of copper. First thing I'm going to do, when in doubt, convert to moles. And 1 mole of copper, there are, let's see, copper's molar mass, 63.55 grams of copper. Now I want to get out of copper, go into silver, so I have to do my equation molar ratio here. And so my 1 mole of copper and 2 moles of silver goes on top. I got the 1 mole of copper because that's a 1 right there, and the 2 moles of silver because there's a 2 right there. All right, but I'm not done because now it wants grams, so I need to convert that to grams. In 1 mole of silver, there are 107.87 grams of silver, and I got that number directly off the periodic table. That's the mass of silver. All right, so I'm going to put this in my calculator, multiply all the way across the top, all the way across the bottom, divide, and I get 123.2 grams of silver. All right, and that is our intro to stoichiometry. I really hope that you have enjoyed your stay. Welcome back.